Hello, welcome to homework number 5, tangent lines. We are still in our circle unit, and a tangent line is something that touches the circle in exactly one place, one point. So today we're going to learn that a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So if this forms a right angle, then it is tangent. Or if it is tangent, then it forms a right angle. So both the if and only if. So both the inverse and the converse will work, or the conditional and the converse will both work. So to test this, if this is a right angle, then the Pythagorean theorem will hold true. So we're going to see if 8 squared plus 15 squared is equal to 17 squared. Well, if you know your triples, you know that yes, indeed it does. Or you can plug this in and figure out that that is 289, and this side is also 289. So yes, it is going to be tangent. Now here, when we look at this, this is where we want to test to see, is it a right angle or not? Well, obviously, 5 cannot be the entire hypotenuse because 5 is shorter than both of those two sides. 5 only goes from B to the circle. You see here that there was a longer line drawn showing it was the entire hypotenuse. So we first have to figure out the entire hypotenuse. Looking at this, I hope you notice that this is the radius. The radius here is 11. And this part right here is also the radius. So this is also 11. Therefore, this entire segment would be 16. So then we want to test 11 squared plus 14 squared to see if that is equal to 16 squared. If we do 11 squared plus 14 squared, we will get 317. 16 squared is 256. These are not equal. Therefore, this is not a right angle. So no, that line is not tangent. To be tangent, it would have to be perpendicular to the radius. Another fact, if two segments from the same external point are both tangent to the circle, then they are congruent. We know that these are both tangent because they form a right angle with the radii that is drawn to there. So therefore, segment AB is congruent to segment BC. Another fact, if a polygon is circumscribed around a circle, so we have a circle and the polygon is around it and tangent in those 3 points, then all the sides are tangent. So that's why they're tangent. Now, going back to this one, P is an external point that is tangent to 2 places. Therefore, these 2 segments are congruent. M is an external point tangent in 2 places, so these 2 segments are congruent. Likewise with R, those 2 will be congruent. That's going to come into play this unit or this lesson. Example 3, if we want to find the length of SV, we want to find this length right here. Well, we know that these are perpendicular, therefore these are the points of tangency. If S is tangent to a circle in 2 places, these 2 are going to be congruent. So 10x minus 41 will equal 4x plus 7. To solve that, we'll subtract 4x from both sides, giving us 6x. We'll add 41 to both sides, giving us 48. Divide both sides by 6, and x will equal 8. It's not what the question asks, though. The question says, what is the length of SV? So to find the length of SV, we first have to plug an 8 into here. 10 times 8 is 80, minus 41 is 39. I always like to double check on both sides to make sure that they are congruent. So 4 times 8 is 32, plus 7 is also 39. So that was correct. We still need to find here. Well, if the radius is 7 there, it is also 7 here. So this is the hypotenuse of this triangle. So we'll do 39 squared plus 17 squared is equal to SV squared, or I'm going to just call it right now C squared. So if I do the square root of 39 squared plus 17 squared, I will get that that is to the nearest hundredth 42 and 54 hundredths. And units, there's no units here. Example 4, we want to find the perimeter. If we remember that point that was made on the first page, D is an external point that is tangent in 2 places. Therefore, these are going to be congruent. If this is 11, this also has to be 11. This is 9.5, so this part is 9.5. Now, DE is 27. If DH is 11, that tells us that HE is 16. Here's an external point. So this segment and this segment are going to be congruent. So that is also 16. To find the perimeter, we add up all the sides. Now, sometimes people add too many numbers here. You can either add the 27 or the 11 plus 16. I like to add this, so I cross that out if I want to make sure I'm doing it right. So we're going to add all these numbers. So basically we have 11 times 2 plus 9.5 times 2 plus 16 times 2, and we will get 73. So our perimeter here is 73. Example 5, we want to find the length of x. X only goes from the circle to the end. Well, that doesn't make a right triangle. I know this is 9 right here, so I could do the quantity 9 plus x squared plus 9 squared. What I personally like to do is I like to just give this whole thing a different variable and say, okay, I'm going to call that entire hypotenuse c. So I would do 9 squared plus 40 squared equals c squared. So here, I know this is a triple, but here I'd get 81 plus 1600. And when I square root that, I will get 41. So c is 41, but I'm trying to find x. So if this whole thing is 41, and I know this part is 9, I just do 41 minus 9, and x will equal 32. Sometimes I can't just do that. Sometimes I do need to actually use my quadratic equations, but we've already talked about that in distance learning. So if you need to go back and review that, you can. And that is it about tangent lines today. Thank you.